Factors controlling landform development. Introduction. The Earth's surface is a dynamic mosaic of landforms: mountains, valleys, plains, plateaus, deltas, dunes, and countless others. These landforms are neither static nor accidental. They evolve under the influence of multiple natural processes and controlling factors. The study of landforms, or geomorphology, emphasizes not only the description of these features, but also an understanding of the forces that shape and modify them through time. Landform development is a continuous interaction between endogenic forces originating within the Earth, exogenic processes operating on the surface, time, and the inherent structure of rocks. Each landscape is therefore the result of complex and interdependent factors working at different spatial and temporal scales. This thesis aims to analyze the main factors that control landform development, including geology, tectonics, climate, processes of weathering and erosion, time, biological activity, and human intervention. 1. Geological structure. One of the most fundamental controls on landform development is the lithological and structural framework of the Earth's crust. Rock type and lithology. Hard, resistant rocks, granite, basalt, quartzite, form rugged terrains, high mountains, and prominent ridges. Soft, less resistant rocks, shales, sandstones, limestones, are easily weathered and eroded, producing valleys, basins, or plains. Differential weathering of rocks with contrasting hardness results in cuestas, hogbacks, mesas, and buttes. Structural controls. Joints, faults, folds, and fractures direct the course of rivers, valleys, and even mountain ranges. Rift valleys, e.g. East African Rift, block mountains, e.g. Vosges, Black Forest, and anticline-syncline mountain systems exemplify how tectonic structures govern topography. Karst landscapes in limestone areas are directly linked to rock structure and solubility. Thus, geology provides the foundational blueprint upon which other processes operate. 2. Endogenic forces. Tectonic and volcanic activity. The Earth's interior is restless, and its movements shape the grand scale of landforms. Tectonic uplift and subsidence mountain chains such as the Himalayas and Andes owe their existence to orogenic movements, continental collision and subduction. Uplifted plateaus like the Tibetan Plateau or the Deccan Plateau demonstrate the power of tectonic forces in raising land masses. Subsiding basins create sedimentary plains and continental shelves. Volcanic activity. Volcanic eruptions form cones, craters, calderas, lava plateaus, and island arcs. Shield volcanoes, Hawaii, stratovolcanoes, Fujiyama, and flood basalts, Deccan traps, exemplify volcanic control over landforms. Endogenic forces provide the initial relief and large-scale framework upon which surface processes later act. 3. Exogenic forces and surface processes. Once tectonics and geology establish the framework, exogenic processes operating on the Earth's surface sculpt and reshape it. These processes are mainly destructive, denudation, and constructive, deposition. Weathering, mechanical weathering, frost action, exfoliation, thermal expansion, breaks rocks into smaller fragments, particularly in arid and cold climates. Chemical weathering, oxidation, carbonation, hydrolysis, alters minerals and is dominant in humid tropical regions, leading to laterite soils, sinkholes, and deep regolith profiles. Biological weathering caused by plants, animals, and microorganisms accelerates disintegration of rocks. Erosion and deposition. Fluvial processes carve valleys, meanders, floodplains, and deltas. Glacial processes create U-shaped valleys, moraines, cirques, and fjords. Aeolian processes shape dunes, loess deposits, and desert pavements. Coastal processes form cliffs beaches, spits, and bars. Mass wasting. Gravity-induced downslope movements like landslides, soil creep, and rockfalls reshape slopes and redistribute material. Together, these processes act continuously, lowering relief, filling depressions, and redistributing sediments. 4. Climate. Climate is often regarded as the master control of landform development because it regulates the intensity and dominance of geomorphic processes. Precipitation. Heavy rainfall promotes fluvial erosion, mass wasting, and soil erosion. Sparse rainfall favours aeolian processes, producing dunes and deserts. Temperature. Intense diurnal temperature range in deserts produces thermal expansion and exfoliation. In polar regions, freeze-thaw cycles dominate, creating patterned ground, block fields, and periglacial features. Wind and storms. Strong winds in arid regions transport and deposit sand, creating dunes and yardangs. Cyclones and hurricanes reshape coastal landforms dramatically. Vegetation, as influenced by climate-dense vegetation, stabilizes slopes, slows erosion, and promotes soil development. Sparse vegetation exposes surfaces to erosion and deflation. Thus, climate not only determines which process is active, but also influences the rate of geomorphic change. 5. Time landform development is not instantaneous, but spans geological timescales. The role of time is crucial in determining the stage and maturity of landscapes. Youthful stage steep gradients, active erosion, V-shaped valleys, waterfalls. Example: upper course of Himalayan rivers, mature stage well-developed valleys, meanders, floodplains, balance between erosion and deposition. Old stage low relief, extensive plains, peneplains, as per Davis's cycle of erosion. Time allows processes to act repeatedly and cumulatively, shaping landforms towards equilibrium. Even tectonically stable areas experience gradual transformation over millions of years. 6. Biological factors. Living organisms play a significant but often underestimated role in shaping landforms. Flora plant roots penetrate rock crevices, widening them and accelerating weathering. Forest cover reduces erosion, while deforestation accelerates it. Fauna-burrowing animals, termites, and earthworms mix soils and displace materials. Coral polyps and marine organisms build reefs and atolls, significant coastal landforms. Microorganisms. Lichens and bacteria chemically weather rocks by producing acids. Biological factors thus integrate with physical and chemical processes to mold landscapes. 7. Human influence. In the Anthropocene, human beings have emerged as a dominant geomorphic agent. Deforestation and agriculture, soil erosion, gullying, and degradation of slopes due to farming and clearing, urbanization and infrastructure, quarrying, mining, road building, and dam construction reshape terrain at large scales. River regulation and canalization alter natural fluvial processes. Industrial activity and climate change. Greenhouse gas emissions accelerate global warming, leading to glacial retreat, sea level rise, and coastal landform modification. Mining and excavation alter topography artificially. Thus, human activity has not only accelerated natural processes, but also initiated entirely new geomorphic pathways. Interplay of factors. No single factor acts in isolation. Landform development is the result of interaction among multiple controls. Geological structure provides resistance and initial relief. Tectonics uplifts or depresses the land. Climate governs the dominant processes. Weathering, erosion, and deposition sculpt the details. Time allows the processes to act cumulatively. Biological and human activity modify and sometimes override natural trends. For example, the Himalayas owe their origin to tectonic collision, structure. But their valleys, gorges, and alluvial plains are sculpted by rivers, processes, enhanced by monsoon rains, climate, and modified by human settlements and dams, anthropogenic factor. Conclusion. Landform development is a multifactorial process, with each factor, geological, tectonic, climatic, biological, and anthropogenic, playing a distinct role. While geology and endogenic forces set the stage, exogenic processes act as relentless sculptors. Climate dictates their intensity, time allows for maturity, and life, both natural and human, adds its imprint. The study of these controlling factors is not merely academic. It has immense practical value in resource management, hazard mitigation, land use planning, and environmental conservation. Understanding how landscapes evolve under different controls helps societies anticipate future changes, especially in an era where human impact on geomorphic systems is accelerating. Ultimately, landforms are the Earth's memory, a testimony to the forces that have shaped our planet over millions of years and continue to do so today. Thank you so much for watching my video. Please subscribe to my channel. Thank you.